So any questions for me? Did you bring anything to class from anything? Yes, anything? Yes, Ben, you have something for me?
I do. I was looking for that stuff. It's an absolute value inequality.
We haven't talked about those, so hold on to that for 5 more minutes, 10 more minutes, and then I'll take that question. Okay, so back to 1.7 then. You can stop me anytime. Back to 1.7. In 1.7, we looked at linear inequalities. And now I would like to look at compound inequalities. What are compound inequalities? There are two inequalities put together. So I'm going to choose on page 203. Let's start with 56. Always tell me if you think you need another example. I cannot stress enough, I'm begging you, please redo all problems we do in class. Watch the videos if you need to from last class and move forward. Assuming we finish chapter 1 today, between now and Monday, please finish up all homework in my math lab for chapter 1 and the quiz. Okay, please. Okay, so this is a compound inequality. As you see, it has one inequality and it has a second one. But we do not and will not separate them into two inequalities. So we are asked to solve for x. What do you think we have to get rid of first? Towards solving for x. In other words, I have to add 3 to all 3 sides. Excellent. So then 6 less than or equal to 4x less than or equal to 22. Perfect. We have to add 3 to all 3 sides. We have to remove the negative 3 by adding 3 to all 3 sides. Any questions? Any questions here? Is this okay? Okay, perfect. Then what do I have to get rid of next in order to get x by itself in the middle? Yes, we will divide everything by 4. 6 divided by 4 is 3/2. 4x divided by 4 is x. And 22 divided by 4 is 11 divided by 2. And you don't have to do anything. This is your interval notation. Bracket at 3/2 and parenthesis at 11/2. I like to write in front that x can be found in this interval, or x is a real number in this interval. You don't have to put this in if you don't want to. When is this really necessary? If I tell you 1, 2, because this could be confused with what? An ordered pair, exactly. But if I put in front x in, then you know we're only talking about x. There is no y here, and x can be any number between 1 and 2. So I recommend this. There is a mathematical symbol for that. I'm not asking you to use it. I'm not even asking you to use this, but be specific. The mathematical symbol is this, x in the interval. But we are not using that. There is no need. Okay, so do you think we need another compound inequality to look at? Is that a yes?
Yes.
Perfect. Okay. So let's look at 58. Negative 6 less than or equal to 1/2 x minus 4 less than negative 3. Okay, what do we do first? We're trying to eliminate 4. Very good. So we are adding 4 to all 3 sides. So this is negative 2 less than or equal to 1/2 x less than or just less than 1. What are we trying to eliminate now, or have to eliminate now? Yes, how do I eliminate 1/2? Multiply all sides, left, right, and the middle by 2. Excellent. So negative 4 less than or equal to x less than 2. The interval notation is right there. Bless you. Negative 4 comma 2, bless you, the bracket at -4 and the parentheses at 2. So x in the interval if you like to write it. In other words, x can be found right there. And now we are finally ready to look at absolute value inequalities. And that will be the last topic of chapter 1. Questions? Okay, absolute value inequalities. We're going to look at 2. That's all we have. 2 different types. One type that is something like the absolute value of x less than or equal to 2. And the other one, what do you think? The absolute value of x greater than or equal to 2. Okay. So forget about this for a second. And let's just look at what we solved last time. Last time we solved absolute value equations. And here I'm asked to find x value such that the distance between x and 0 is 2 units. What are the solutions here? Excellent. X equals -2, x equals 2. In any order, it doesn't matter. Excellent. So this is the way we solve a absolute value equation. But this is not what we are dealing with at this point. Here we have absolute value inequalities. Let's talk about this one first, and then we'll go back to that. We'll come back to that. Okay. So one more time, what does this say? This says find x values such as the distance from 0 to x is 2 units. So this number cannot not be anything else but -2 because -2 in absolute value is 2. Or this number can be 2 because the absolute value of 2 is 2. Now this one is a totally different story. What does this ask? It says find x such that the distance between x and 0 is what? Excellent. Okay, so if you look at me for a second, we know that 0 is in the middle, and I'm asked to find 2 numbers whose distance from 0 is 2 units, -2 and 2. But now, with the inequality, I'm asked to find numbers whose distance from 0 is 2 or less. One more time, 2 or less. Where will I find those values then? I'm showing you. You just have to tell me what it is. Between what and what? That's it. -2 and 2. Exactly. In between. So this really translates into -2 less than or equal to x less than or equal to 2. All numbers between -2 and 2 have the distance between themselves and 0 less than 2 units or equal to 2 units. Again, there is no need to do anything here. The interval notation is what you see. So what we have to remember is that this translates into this. And we'll come back to the other. And then examples, of course. Okay, now let's analyze the other one. Before we analyze the other one, let me just draw a little graph here. Here it is. This is 0. This is -2. This is +2. Negative infinity, infinity. The absolute value of x equals 2 has solutions. Can anyone dictate them one more time? Correct. So this one is only here. Where will I find the solutions of this, or to this inequality? We just wrote that a minute ago.
Everything in between.
Excellent. That's all I wanted to hear. In between. Exactly. So this is solutions to that. Now finally, stay with me please. We are solving this inequality. I can write it in words if you'd like, or we just discuss it. This says, find the values of x whose distance from 0 is 2 or more. It's not 2 or less, but it's 2 or more. So this will have solutions here, which is way more complicated to write. I shouldn't say way more, but right? So the solutions here are two separate inequalities. X to the right-hand side of 2 and x to the left-hand side of -2. Some of my students say you should change the sign, the inequality symbol. No, it looks like it. We just wrote the solution. It's to the right-hand side of 2, which means this. The key word here is or. The left-hand side of -2. And that key word is important because the solution will be presented with a union from -infinity to -2 and from 2 to infinity. So this is our summary. X greater than or equal to 2 or x less than or equal to -2. So do not erase anything or cross out anything. I'm making a point. This translates into this. This translates into this. We cannot solve these if we don't know how to convert them and what replaces them. This I cannot solve, but I know that this one replaces it, and this I can solve. This I cannot solve, but this replaces that. So I know, once I know what to replace it by, I know the solution. And now let's practice these. Any questions from me before we practice with different situations? Yes, ready? Okay, so let's start with, let's say 66. The absolute value of 3, x minus 1, plus 2, less than or equal to 20. Remember we said the absolute value symbol is not a grouping symbol. I cannot do anything, bring in anything, take anything out. But inside it, I can perform the regular operations in order of operations, right? I can. So I will say, I will write 3x minus 3 and plus 2 less than or equal to 20. I have to clean it up first. It's not ready for any discussion. That's why I'm simplifying it as much as possible. So then this is 3x minus 1 less than or equal to 20. Only now I know that I cannot, don't erase it like that. I'm just making a point. I don't know how to solve this, but I know how to convert it into something that is equivalent. And that other something, the second step, the translation, I know how to solve. So I only have to identify which one it is. There are only two. Is it the one in between, or is it the one outside?
In between.
Perfect. Let's read it. How do I know? We just have to read it. Find numbers whose distance from 0 is less than or equal to 20. It must be in between. -20, 3x minus 1, 20. You do not have to memorize anything. Once you understand it, just read it. Find numbers whose distance from 0 is less than or equal to 20. So it must be in between. Is it done? No, it's not. I have to clean it up and get x. How do I clean this up? What will be the next step? How do I simplify everything here? Of course, I will add 1. So this is negative 19 less than or equal to 3x less than or equal to 21. I did add 1 to all 3 sides. Perfect. Now what? We divide all 3 sides by 3. So you know that this is now a compound inequality. That's why we solved the compound inequality before getting to the absolute value inequalities. So negative 19 thirds and x in the middle and 7. The interval is right there. I don't have to do anything. I don't have to write the union. I don't have to intersect. It's already intersected for us. If you want to put x is found in, fine. If you don't, it's fine. It's okay. Any questions? Any questions? Can we choose the next one then? Yes? Okay, so let's look at another. Let's say the absolute value of 2x minus 1 greater than or equal to 3. 85. They're all on page 203. Okay, all I have to do is just read it carefully and identify the type. Is it type 1 or type 2? Type 2. Perfect. Because you already read what? Find numbers whose distance from 0 is 3 or more. 3 or more means outside. 3 or more. So then I have to write two separate inequalities that I will combine the solution using the union symbol. So what will be the first inequality? 2x minus 1 greater than or equal to 3, perfect. Or 2x minus 1. That's it. Nothing in between. It has to be completely outside. Good. So I add 1, 4, and divide by 2. I add 1, I get negative 2 divided by 2. Let me know if this is clear. So one more time. I'm adding 1 to 3, and I get 4. And I divide by 2, so I get x greater than or equal to 2. Is this okay?
Yes.
Please say no if you don't see it, and I'll go back. I'm adding 1, but now I'm getting negative 2 here. But negative 2 divided by 2 will be negative 1. And now please tell me how to write the solution. In this case, the solution has to have the union symbol in between. The first one has to start with negative infinity, and the last one has to stop at infinity. Yes, to the left of negative 1, and to the right of 2. I would like to choose a couple of word problems here, unless you want us to practice some more of these absolute value inequalities. Please let me know what you'd like. But this is the end of chapter 1, but I would like to look at a couple of problems. Ready? Okay. Would you like to practice more of the absolute value inequalities, or are we in the clear with that? It's up to you. Are we okay? Okay, so I'm looking at this problem, 129. An elevator at the construction site has a maximum capacity of 3,000 pounds. When I read something like this, I'll come back, of course. When I read something like this is what goes to my mind immediately. It has a maximum capacity. It cannot be exceeded. So whatever I write here, I don't even know what I'm going to write. But this has to be less than or equal to 3,000. The elevator will not move up or down, or mainly up, if it exceeds 3,000 pounds. Okay, so now let's go back. This is what I see right away. Maximum capacity. If the elevator operator weighs 245 pounds and each cement bag weighs 95 pounds, how many bags of cement can be safely lifted on the elevator in one trip? So maximum 3,000 pounds, a person of 245, and each cement bag 95. So what do I write on the left-hand side? So I will write 295. Oh, no, it was 245, right? Okay, 245 plus 95x. And this, of course, turns into a linear inequality. Do we understand what we just wrote? Do you understand where it's coming from? Everyone? So the person weighs 245 and each cement bag 95. In order to be safe, we cannot exceed 3,000 pounds. So we want to know how many cement bags we can put in the elevator in one trip. Okay, so what do we do first? Very good. So 95x less than or equal to 5 from 0 is 5, 4 from 9 is 5, and 2 from 9 is 7, and I think I have 2. Correct me if I'm wrong, please. Let me know if you got the same thing. I was just lazy. So 5 from 0 is 5, 4 from 9 is 5, 2 from 9 is 7, and I borrowed the 1, so I just didn't write it. Sorry. So then x less than or equal to 2755 over 95, and that I will do with a graphing calculator not to waste your time. So 2755 divided by 95. 29. So you would say, well, but this in interval notation is this. No, it is. That's true. We are talking about number of bags. So I would have to restrict between 0 and 29. Although this is the correct mathematical form of the inequality of the solution in interval notation of x less than or equal to 29, but I can have -5 bags of cement in the elevator. So I have to think about that, and I just put the interval that makes sense. Okay. I'd like to look at 130. To earn an A in a course. Any questions on this problem, 129? And that was, I'm sorry, on page 205. 205. Okay. So in 130, same page, 205, we're told, to earn an A in a course, you must have a final average of at least 90%. In order to earn an A in the course, so you must have a final average of at least 90%. Exactly. Here I was told it cannot exceed. So whatever, it has to be less than or equal to 3,000. Here it says, in order to pass or whatever with an A, the average must be at least 90, which means 90 or more. Is this understood? Okay, then let's read on. On the first 4 examinations, you have grades such and such. If the final examination counts as 2 grades, what must you get on the final to earn an A in the course? So we have 4 examinations, and the final exam counts twice. So we have 4 tests, and the final exam that counts twice. So how many grades basically we have? 6. How do I determine the average of 6 numbers? Exactly. Add them all up and divide by their number. So the average of 6 numbers will be the sum of those 6 numbers, and we divide by their number. If I had 5 numbers, I would have divided by 5. If I had 2 numbers, I would have divided by 2. Is this okay? Okay, perfect. Now let's see. They're telling us that we have 86 on the first test. We have 88 on the second one. We have 92 on the third one. We have 84 on the fourth one. And then we have an unknown counted twice. What should I write in here? 2x. So it's plus x and plus x, but that's 2x. An apple plus an apple. Any questions so far? This is an inequality that we have to solve. The average, please remember, is the sum of the numbers we are trying to find the average for, and we divide by their number, in this case 6. So I'm going to add these 86 to 88 to 92 and to 84. I got 350. So the simplified form of this inequality is 350 plus 2x divided by 6 greater than or equal to 90. And now please tell me, what will you do next? Yes? Say it again. Not right now. First, I have to remove something else. Multiply both sides by 6 to clear that. And then, indeed, of course, now I will have to move 350 to the other side. So 2x greater than or equal to, is it 190? Correct me if I'm wrong. So then, what should be our final exam grade? So 19 divided by 2. Yes. So in order for us to get an A in this course, the final exam grade has to be 95 or above. 95 is the minimum. It can be anything. Of course, I'm not going to write the interval notation as 95 to infinity. That makes no sense. Right? So it's whatever the maximum number of points I can ever earn on that exam. Maybe 110. Maybe there is bonus points. So if you want an interval notation, I will write it like this. If the maximum is 100, if the maximum, like on all my tests, I have 110 because I'm adding bonus points that you can even get 110%. But I don't know. Or you'll say, well, I don't need to write an interval notation. I will just write in words at least 95% I should get on the final exam in order to get an A in the course. Yes. Parts for an auto repair cost $175. The mechanic charges $34 per hour. If you receive an estimate for at least $226 and at most $294 for fixing the car. So the parts are $175 but plus labor. And the mechanic tells you, I wish they would tell me that, minimum will cost you $226 but not more than $294 for fixing the car. What is the time interval that the mechanic will be working on the job? So he charges $34 per hour. That's unheard of. The book is too old. They don't charge $34 an hour. So I wish they would. Okay, so this problem is 132 on page 205. So we are told parts. I always taking notes when I read a problem. Parts 175, labor 34. So the estimate is min 226, max 294. How many hours will he be working on the job? Say it again. Exactly. Very good. And it's wise to write it down what it is. X, number of hours. Excellent. There is an R in there, but squeezed. Okay. So, what do you think? How do I set this up?
26 is less than
Perfect.
175.
Perfect.
34x.
Perfect.
Greater than
Careful. In between.
Oh.
Greater or less than 294. Excellent. Well done. That's what I wanted you to see. So if I tell you I have in my pocket anywhere between $2 and $10, you know how to write it, right? 2, right, is less than or equal to X, less than or equal to 10. That's in between. That's all I needed. Okay, perfect. How do we solve this? This is obviously a compound inequality. Two inequalities put together. We will not separate them because it becomes more difficult. So this is not difficult now. What do I do first? Of course, subtract 175 from all sides. So in the middle, I have 34x. And then 175, I have, I think it's 911. Correct me, please. And here, 175 will be 15. Finally, what do we do? Correct my numbers, please. In the last step, we divide by 34 everything. 51 over 34, x 119 over 34. I perform my calculations. 51 divided by 34 is an hour and a half. And 119 divided by 34 is 3 hours and a half. Yes, I can write this in interval notation, 1.5, comma 3.5. From the sections we studied, there is a review section. Do not choose anything else. There is no need. Than the sections that we covered. And do as many problems, all these problems, odd or even, doesn't matter. They have the answers in the back. So I will definitely focus on review for all the sections that we covered. Also, there is a chapter 1 test. Just focus on the problems that we did. If you, for example, encounter something like this, we didn't cover division of complex numbers here. We don't need that for this course. Okay? So don't do that. But everything else, it's a perfect practice. And that's when you say, I got chapter 1 under my belt. I'm getting all the answers. If not, come back on Monday with a list. I tried this, it didn't work for me. I tried this, it didn't work for me, and we'll do them in class. Okay? That's the only way to say, I'm done with this. I know what it means. I'm fine. Okay, chapter 2 is a long chapter, so I decided to cut it in half. Half in test 1 and half on test 2. It is possible that we are going to cover 2.1 through 2.5, or I will change because I can't have the first test too far out. It will conflict with the other tests, and we need a lot of practice, and I always use a full session to review. I will bring an old test, I will give it to you before we review, and you'll work on it as much as possible, and then we'll work on it in class, okay? I was just checking the time. Okay, so it is possible that we are going to use just these 4 sections. It shouldn't be a problem. There are a few items in here that are probably new to you, but the rest between 2.1 and 2.4, no cell phones, please, should not be a problem. Okay, so chapter 2 is all about functions. Many of these topics are known, but I'm going through everything. So, first of all, do we know what a function is? I'm not testing you on definitions, but we need to talk. That's one example. Here's another example. And here's a third example. You can say, what is this? Well, I didn't put anything in there yet. So, give me 3 numbers. -4, 3, and
7.
Excellent. Give me the same numbers if you want, or other numbers.
2, 2.
And 0. Okay, and 3 more.
-5.
0 and 2. Okay, perfect. So I have a set of numbers, and I'm going to create another set of numbers. I'm going to say A, B, and C. They're numbers. I have here D, E, and F numbers. And here I have A, C, and D. And I'm deciding this. I'm going to link these two. I'm going to link these two, and I'm going to link these two. In the second option, I'm going to link these two, and then these two, and then these two. Careful. And then I'm going to link these two, and then these two, and then these two. So let's go back to the first situation. Each number that you gave me was connected to only one element in the second set. These don't have to be letters. I just found it easier to put letters in there instead of numbers, of course. Doesn't matter. So if for each element from the first set, to each element from the first set, it corresponds only one element in the second set, then we call that a function. Okay? Each x, these are the x values. And of course, these are the y values. This is called domain. And this is called range. Perfect. Say it again. Domain. Sorry about that. So domain and range. Domain, I pick x from, and range values of y. This is a function, one more time. Each x corresponds to only one y. Let's look at the second scenario. Does each x correspond to only one y? Does each x correspond to only one y? Does each x correspond to only one y? Yes, so this is also a function. What about this?
No.
No, because I found one element in the first set that corresponds to two elements in the second set. Is this possible? Yes, it is, but it's not a function. It's some sort of relation, some sort of link between the two sets, but it's not what we call a function. Is it possible? Yes. So what is the domain of the first function? Domain of the first function is -4, 3, 7. Just three elements. What is the range of the first function? ABC. What is the domain of the second function? 6 to 0. Range, DEF. What is the domain of the relation? -5, 0, 2. What is the range of the relation? ACD. So if I'm given the relationship, I can identify whether I'm looking at the function or not. Also, if I'm given the graphs, I can be given graphs and asked, identify functions and relations. So I'm just going to pick a few graphs. Here's one. Here's the other. Here's another one. And let's say this one. This time I'm given graphs. I'm not given the link, the relationship, how one side connects to the other, how x connects to y. No, instead, I'm given a graph, which indirectly I'm given how x is connected to y. So let's start with the first one. Does this graph represent a function? No. By the vertical line test, for this x value, I don't know, 3, it crosses the graph in 2 points. Therefore, I will read 2 different y values. So this is a relation, not a function. By the vertical line test. What about the second one? Is the function or relation? The next one. Excellent. And the last one. Very good. Now let's look at graphs. Our next step is to identify domain and range from graphs and also answer a few questions. So, of course, you choose. Please choose whatever you want. 81, 82. Okay, perfect. Let's look at 82. Okay, we have a lot to discuss about 82. I can tell you a lot about this function. First question, is it a function? By the vertical line test is a function. Question number 2, what is its domain? Don't answer just yet. I see this function is between these values, right? Between -6 and 0 for x. But I see an open point here, and I see a full point here, which means this point exists, that one does not. So how do I write the domain of this function? Say it again.
To parentheses, -6.
-6 to 0. Very good. So the domain of this function is indeed between -6 and 0 on the x-axis. This function does not exist at 2. We say undefined at 2, as an example. It does not exist at -7. By the vertical line test, it doesn't hit. So this must be the domain between -6 and 0. Is that clear?
Yes.
Okay. Now I want to determine the range. The range is from the lowest y value to the largest y value. But again, this point does not exist. So how do I write the range? Between -3 and +4. I can also say about this function that as x goes from -6 to 0, what does the function do? Decreases. The function decreases. As x goes from -6 to 0, the function decreases. I'm going to ask, what is the x-intercept? Does it have an x-intercept? Yes, it's right here at -4, 0. It crosses the x-axis at -4, 0. Does it have a y-intercept?
-3.
Yes, we will write 0, -3. It's an ordered pair. Now I'm going to ask, find f of -5. How do you find f of -5? And what does f of -5 mean? Let's talk about this before we identify it. Okay. So, notation for functions. F of x. Not f parenthesis x, not f times x. This is just the name. We read it f of x. It can be p of t. It can be v of p, and so on and so forth. So when I'm asked to find f of -5, I'm specifically told x equals -5 and find the y value of the point. So x is -5, find the y value of the point. And now I go back to my problem 82.
You just chose -5.
I just picked -5, yeah. So when x equals -5, I draw a vertical line. It crosses the graph here, and I will approximate, which is not easy, but I will approximate and say 1.8. I'm fine with 1.8. What about f of -3? I draw a vertical line at -3. It crosses the graph. -1.2. Very good. Now I want something else. I want to find the x when f of x is 3. I want to find x when f of x is 3. What am I given now? The y value. So now I have to imagine that I draw a horizontal line at 3. It crosses the graph here at this point, and I will be reading the x value. I accept that. Difficult to read, but the mechanism is important, not necessarily the ordered pair. Any questions on this? Any questions? Okay. Let's look at one more. This one. We are going to see this function in chapter 3. So I'm interested in looking at this function, and I'm hoping that you notice that this function is defined everywhere, everywhere. Yes, 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 no. At this point, at x equals 1, the function is not defined. Would you agree? But then it continues to exist. So can anyone give us the domain of this function? From -infinity to 1, union 1 to infinity. Perfect. What if I ask you find f of 2? What will you say? So when x equals 2, it's roughly, I'm going to say 1. What about the range? Now I go this way. When I determine the domain, I go this way. When I determine the range, I go from low to high. Yes, 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 yes. No. Yes, 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 yes. So what is the range of this function? From negative infinity to union 0 to infinity. Excellent. Excellent. Now I would like to ask you, does this function have x-intercepts? No. Does it have a y-intercept?
Yes.
0, comma, negative 1. Is this function decreasing or increasing? As x goes from left to right, follow my hand.
It's decreasing.
So it's always decreasing on the entire domain. Finally, what about this? So what is the domain of this function? Careful. You cannot use parentheses or brackets. You will say the domain is negative 5, comma, negative 2, comma, 0, comma, comma.
3.
Perfect. Now what about the range? That's it. Just 2. Just 2. Very good. Okay, perfect. That's all I needed from here so far. We know how to evaluate. We know the notation. I would like us to look at some expressions, some functions, and evaluate them. I have time? Yes, hold on 1 second. I need to